Your friend has an RC circuit and tells you that the current, when the elapsed time equals the time constant, is 2 amps. Your friend also tells you that after 5 seconds, the current is 0.75 amps. Determine the initial current and the time constant. Now notice that your friend hasn't told you if it's the charging case or the discharging case. And that doesn't matter because the current in both cases behaves the same. In both cases, the charging case and the discharging case, the current undergoes exponential decay. Now that's not true for the charge on the capacitor or the voltage across the capacitor, but it is true for the current. The current behaves the same in both cases, charging and discharging. Additionally, the time constant is calculated the same. It doesn't matter if you're talking about the charging case or the discharging case. The time constant is R times C, the product of the resistance and the capacitance. Now in this case, we are told that when T equals tau, the current is 2 amps. Okay, so plugging that into the formula, 2 equals I initial. This is going to be E. So T is, instead of being T, it's going to become tau. So, of course, tau over tau, that cancels. And so I'm left with, it just becomes, well, tau over tau becomes 1, but then I've got the minus sign in front, so this is E to the minus 1. And that just means this is the initial current over the exponential function. And so I just take 2 times the exponential function to get the initial current. And it works out that the initial current is approximately equal to 5.437 amps. So that's the initial current. Now let's do the second part, where we are trying to figure out the time constant. So in the second case, we're told that when T equals 5 seconds, I equals 0.75 amps. Okay, well, let me write the formula down again. I equals I initial, e to the negative t over tau. Okay, I is going to be 0.75. I initial, I just solved for that. That's the 5.437. And then I've got e to the negative 5. It was 5 seconds over tau. Okay, well, I'm going to take 0.75 and I'm going to divide it by 5.437. That's going to give me e to the negative 5 over tau. And now what I have to do is I have to take the natural log of both sides. So at this point, I need to take, let me just write this out in all its glory, the natural log of 0.75 over 5.437. And I need to take the natural log of e to the negative 5 over tau. But taking the natural log of the exponential function just gives us the power. It just gives us this. These effectively are canceled out and you're just left with this. And so it just becomes negative 5 over tau, like so. So if I'm solving for tau, that means I'm going to do negative 5 over the natural log of this big ugly looking fraction. And so, oops, just plug that into the calculator. And it works out to be 2.524 seconds, approximately. And there you go.